I'm sorry about the pineapple thing. They asked for a controversial opinion, and that's the one I went with because it does not belong on pizza. I'm sorry. We can talk about that later, though. Hello, thank you for having me. I've never been to RubyConf before, so this has been really fun for me. I want to start off my talk by saying thanks to Burnt Toast Creative for allowing me to use the illustrations in my talk. It is why it looks so pretty. And very importantly, this is my dog Jello. The reason I'm mentioning it is because I use the word a bit in my talk, and people get confused and think it's the food. So today we're going to be talking about HTML, and we're going to be looking at how you can utilize it to improve the performance and accessibility of your websites and applications. And I know HTML, that's got nothing to do with Ruby, and everyone knows HTML, but I think it's true that HTML is very simple, right? I'm very upfront about that, but because it's simple, we often make the mistake of assuming that it's not valuable. And I'm hoping to dispel that way of thinking today because it's something that we use a lot, and it plays a really pivotal role in making good functional websites. And what makes it functional is the DOM tree, which I'm sure you're all familiar with, or the document object model. And it's constructed off what we provide the browser, typically via HTML. We specify whether we want a heading, what kind of heading it should be, a paragraph, a date, a form, a label. And there's a whole suite of elements we can choose to best represent our content. And then, of course, there's the div, which has no meaning and doesn't mean anything. When you use a div, it means the content can be anything. But if you choose a generic element, you're going to get generic output. And you lose the benefits of the language when you try and use this everywhere. And this generic output is hugely problematic for assistive technology, for accessibility, and other tech that try and read our HTML to infer information about the page and content. Because not everyone and everything is going to interact with your page the same way. There are many technologies that try to use, read, and consume our content and rely on us using the languages correctly in order for it to make sense. Whether it's Google search bots or reading apps like Safari's reading mode, text-to-speech tools like Alexa and Siri, or accessibility tools like screen readers, it's not just our eyes that are going to consume our content. And the DOM and the HTML play a really big part in how successful that can be. Now, like the browser creates the DOM, it also takes the DOM tree and it modifies it to form something that's useful for assistive technology. And that's called the accessibility tree. It takes the native semantics of HTML and it creates an interface for reading and navigating a page. A screen reader, for example, is able to interpret the accessibility tree and reproduce it as speech. Major browsers like Chrome and Firefox have accessibility tree inspectors that allow you to look at the accessibility tree. This one is specifically from Firefox. Because the accessibility tree is made up of what we provide the DOM via HTML, if we don't utilize HTML well, what it generates is not very good. This page about my dog Jello, or dogs in general actually, is just made of divs, including the links at the top, which have an on-click event. And all you get from the accessibility tree is a bunch of sections and text leaves. If you compare that to a page that uses more meaningful HTML, you can see there's a lot more information here. Paragraphs, graphics, block quotes, separators, landmarks. There's a more defined and meaningful structure. A really good way to demonstrate this is actually with a screen reader, so we're going to listen to that. We're going to use Apple's VoiceOver for Mac, and we're going to look at the div page first, so let's have a listen.
Home. Good dogs. Bad dog myths. Dogs. They are good. We are dedicated to educating the world on why dogs are good
my dog
and how
propaganda.
they can make your life good. By Mandy Michael, August 3, Road 2018. Why are dogs good? Dogs are loyal, intelligent, devoted, and affectionate. They are known to improve our physical and mental health. Jello, also known as Jello. /screen %, 20, shot %.
Okay, terrible image. It was a screenshot from Instagram. I didn't rename it, and I didn't use an alt attribute, so it reads out that really terrible file name. Now, this was not very good. If you didn't notice, it said 3 road instead of or third for the date. It didn't tell us that there were links in the page. And the reason it didn't tell us is because as far as the accessibility tree is concerned, it's just text. It doesn't know the on-click event is there. So in comparison, let's listen to the one with better HTML.
Navigation main navigation 1 item. List 3 items. Visited. Link. Home. Link. Good dogs. Link. Bad dog myths. Heading level 1. Dogs. They are good. We are dedicated to educating the world on why dogs are good and how they can make your life good. Mandy Michael. August 3rd, 2018. Heading level 2.
Okay. I won't make you listen to the image again. It is better, but I feel like my point was made. This is a really simple page and a very small part of a really simple page. And the differences are quite noticeable. It told me how many links there were, that I'd visited a link, that something was a link. It read out headings. The date was better. And all I did was pick HTML that represented the content. And now we have a functional page. Prior to that, it was not very functional, and the user had to do a lot of the heavy lifting and take on the cognitive load to try and figure out what was going on. But it's not just accessibility that benefits from a more considered approach to HTML. Overlooking HTML can lead to a very large, complex DOM tree. And this can have an impact on your load times. As users and scripts interact with your DOM, the browser has to recompute the position and styling of all of the nodes. And this can severely impact the rendering time and the runtime performance of your pages and applications. Google's Lighthouse Performance tool recommends less than 1,500 nodes. It'll warn at 800, so that should be an indicator that you want to be way on the low end of that. Max depth of 32 nodes, that kind of thing. Now, you might think that's a lot, I'll never hit that, but more complex pages, especially in web apps, with lots of widgets and tools and features, can easily exceed this by mistake, especially if you're building at a component level. These days, we build an isolated component, and it's like a wrapper div there, and a wrapper div in that component, and a component wrapper with more divs. It's very easy to forget that all of these things have to come together on one page. And while you might check that the component works, most people don't check what the actual HTML is on the page. They've just checked the functionality. And as the accessibility tree is made up of what we provide the DOM, any performance impacts to the DOM further impact the accessibility tree. So I saw this great talk by Eric Bailey, who's an inclusive design advocate. And he says that when the accessibility tree is slowed down by excessive code, it can create a lack of synchronization between the current state of the page and what is being reported via assistive tech. This results in a mismatch between the page and what the user is presented with via the accessibility tree. So as you can probably imagine, that's very confusing. You can kind of think of it like bad lag in a video game or bad dubbing. For example, it's confusing and they have to do a lot more work to figure out what's going on. Worst case scenario, it's going to crash the browser. At the end of the day, everything that we put into our page impacts our performance and our accessibility. And that includes every div, every button, every link. Everything adds up to create these negative experiences with performance and accessibility. So we need to dedicate some time to how we use our HTML. So this was 8 minutes of me talking to basically say don't just use divs. I'm not saying don't ever use them. They have a purpose. Just don't only use divs. And when you are using HTML better, use them correctly. For example, headings. They're very important. And they're numbered for a reason. We're good with numbers typically. Use them in order. They provide a clear structure and hierarchy for the page, and when you use them out of order, you mess with that hierarchy. Headings are important for a number of reasons. Google Search Bot uses them for prioritizing content and figuring out what's important. It's also part of that little search preview in Google. But importantly, they're very important for accessibility because users using assistive tech use headings typically to navigate the page via tooling. And that might be with keyboard shortcuts through a screen reader, or something like the rotor, which is up on screen, which is kind of like a table of contents. It'll group things like links, headings, landmarks, and allow people to navigate through and jump to a section on the page. So if you don't use headings, and you don't use them properly, you're taking away the user's ability to navigate your page, which that would be like having no navigation and trying to figure out where you needed to go by some imaginary lucky dip. We should also use the appropriately named element for what we're building. If you have a header, use a header. A footer should be a footer, a nav should be a nav, article, article, label, label, form, form, button, button, section, section, image, image. HTML is intentionally simple. It's named to help you out. It's not a trap. Nobody's trying to trick you. And look, I'll be the first to admit it's not always that simple. We've got link and anchor, which is confusing. And sometimes it's not obvious what something should be, but it's a really good place to start because it is trying to be helpful. It will improve your accessibility just by changing the HTML. So if that's the only thing you do for accessibility, that's a big step forward. In some cases, it might also reduce the number of nodes on the page because you're simply being more considered in your approach. More often than not, you should also make the most of built-in functionality over creating your own. I know this isn't always easy to do, but it's a good place to start because there's a lot of useful built-in features that don't require additional JavaScript. Now, I'm not sure on the Ruby community's position on JavaScript, but as a front-end developer, I have to say we definitely could do with less of it in our websites. So if you can use native functionality, you can have less of that. It also tends to work better across mobile devices and for accessibility as well. Not always, but typically it's a lot better. Definitely better than Stack Overflow code. Might be better than ChatGPT and Copilot. Don't know, that might change over time as it gets smarter. There's some good things you can use, like details, which is like an accordion. The date picker, which I'm sure you're all familiar with. Actually, this one's an interesting one, right? I'm going to take a moment here. Date pickers are great for discoverable dates, like appointments, like next Tuesday in 3 weeks. They are not great for date of birth, especially the older you get. I don't like having to click back to the 1900s to find my year of birth. It's a very humbling experience. There's a great article called You Might Not Need a Date Picker by Adrian Roselli. It's in my resources. I highly recommend you read it. You can just use a text input for date of birth. Another situation you might come across with these is where you get a design and it's pretty and it doesn't match the native style. What I would say about that, between us, just because it's in a design does not mean you have to do it. Controversial, I'm not saying be a jerk about it, but there's always room to have these discussions with designers. There's always room for compromise, especially if it's going to make functional, accessible improvements to your page. So don't feel like just because it's in the design, it's something you have to do. Definitely ask about it if you can. That said, there's also things with really good styling options, like the dialogue, which is kind of like a modal where the page behind it is disabled. Another option is the popover, which you're like, Mandy, that's exactly the same as a dialogue. But it's not. It does not disable the page. This is better for toast notifications, content pickers. It's actually kind of new. It's been supported in the browsers as of like a month ago. There's also a JavaScript API, but who cares about that? And of course, the button. Buttons have lots of useful features, but typically people these days do this. And I know we had the 8 minutes of don't use divs, but I wanted to show my little table here because it really drives the point home. Buttons have all these features. Specifically, they're very good for accessibility. Announce via assistive text, keyboard interaction, focusable, reported to the accessibility tree. Divs, however, none of that. If you use a div, to replicate these features, you need to write more code, test more code, and maintain more code. And that means you've got more JavaScript on your page, which we've already established is a bad thing. I mean, I love JavaScript, don't get me wrong, but you don't need it to make a button when we already have a HTML element. Don't make your life more difficult. When you make use of native functionality, it's basically like using a JavaScript library that's already built for you. This means less JavaScript, smaller JavaScript bundle sizes, which improves the performance of our pages, which is what we're going to talk about for the next 15 minutes, specifically about performance. And we're going to focus first on images. Now, I almost didn't include this next bit because I called it advanced HTML, and this really isn't advanced HTML, but it is very important because images take up more bandwidth than any other resource, and they tend to have the biggest impact to performance of any other resource. And one of the simplest things you can do in HTML to get around this is adding a width and a height to your images. This is going to improve the effects of the cumulative layout shift, which I'm so proud I just said that word right, because I had to practice it so many times. Let's see if I can say it right again. The cumulative layout shift is a performance metric that measures how much elements shift on the page as content is being downloaded. And this is really important for images, because typically there's a delay between the HTML and the image being downloaded. And this can cause any content below the image to shift down the page, which is really disruptive, right? Especially if you've already started reading. Very common on mobile devices because of the smaller screen real estate. The additional with this for browsers is if you have a lot of images in your page, you can significantly increase the work of the browser as it has to recalculate the layout as each image is downloaded. So it's very important in those scenarios. So by adding a width and a height, we can reserve the space for the image, meaning it's not going to shift anymore and it's just going to load in place. Now, if you were alive doing web stuff before responsive web design, as I was, you'll note that we used to do this. But then you can't have a 1,000 pixel wide image on a 400 pixel wide screen, so we stopped doing it. In order to get around that, they had to introduce some new things. It's not new, it's been around for a while, but the first one is source set. What source set does is allow you to provide a comma-separated list of images with a width or density descriptor. So density is the DPI of the image. So in this case, we have two images, Jello 1000 with 1000W and then equivalent in 2000. And what this means is that that 1000 is 1000 pixels wide. The browser doesn't need to download the image to know how wide it is. Sometimes people think that the W means viewport width. That is not the case. It is width of the image. If you want to specify something based on viewport width, we have the sizes attribute for that. So in this case, it's kind of like media queries in CSS. You can say, I want, at a min width of 1,000 pixels, I want a 1,000 pixel wide image. And then it'll go to the source set and it'll grab the 1,000 pixel wide image. If there's not one that matches, it picks the next largest one that's available. Now, there are some other things you can do. There's like the sources element in Picture. You can do stuff with aspect ratio in CSS. But what I want to focus on next is lazy loading. If you're not familiar with lazy loading, it essentially defers loading of something, in this case images, until it reaches a particular distance from the viewport. So in this case, you get to look at pictures of my dog. And as we scroll, it loads in each image as you need it, rather than at the beginning of the page load. Sir Gelatin. Previously, we would have handled this by using the intersection observer or event handlers like scroll and resize, but we don't need to do that. We can just use the loading attribute with a value of lazy, and it'll do all the work for you. This is valid on image and iframes. Iframes very handy for this. Only being supported for a little while on iframes in all the browsers. Now, its default value is eager, and it's basically the same as not including it at all. But the reason that I mention it is because some image management libraries will lazy load by default, and that's great because the majority of our images we do want a default lazy load. However, we only want to lazy load images that are not in the viewport when the page first starts loading. If there's an image in viewport when the page first starts loading, it's considered part of the largest contentful paint, which is a performance metric that refers to the largest image or text block that is visible within the viewport when the page first starts loading. If you try and lazy load an image that's part of that, it's going to negatively impact your page because it won't be loaded as quickly as it needs to because you've deferred it. So If you're using a management library for images that does lazy load by default, you do need to reset them back to eager if it's in the top part of your page. Otherwise, you're going to get negative performance metrics. So for the remaining 10 minutes, something like that, we're going to talk about optimizing and loading prioritization. Now, to do that, I'm going to very briefly, very simply talk about browser prioritization. So with HTTP1, we would have multiple TCP connections, and they would load one resource at a time. So prioritization was based on whatever was requested first. But with HTTP2 and HTTP3, this was changed. Instead of the multiple connections, it was changed to a single connection with multiple requests at the same time. But that doesn't mean that every request can be responded to at the same time. And that's because a connection is limited in how much data it can send. This is particularly true at the start of a connection, as we can only send excuse me, a limited amount of data for one network round trip. Eventually, the server has to decide which request is going to respond to first. As a result, the order of prioritization can have a really big impact on your performance, because as it prioritizes one thing, it's going to deprioritize another. If you send the JavaScript first, your images are delayed, and vice versa. And this is particularly important for render blocking things like JavaScript and CSS, because they need to be downloaded in full before they can be applied and executed. Additionally, to complicate this further, browsers prioritize things differently. It is not the same across every browser, so depending on how you have things up, you might see noticeable differences between each browser for your performance. So what can HTML do for this? They introduced priority hints, specifically the fetch priority attribute. Fetch priority allows you to specify the priority of resource types like CSS, fonts, scripts, and images. But what it does is allow us to change that default priority from the browser, and it also gives us the opportunity to try and make things a bit more consistent across browsers. It has 3 options: high, prioritize; low, deprioritize; and auto, which is browser do whatever you want. That is the default option. Now, often when people use this, they expect that if you set a high priority, it's the highest priority. If you set a low priority, it's the lowest priority. But that is not what happens. It actually just sets a relative priority. It's only going to raise or lower the priority by a specified amount. So, for example, this is from Chrome, so web.dev, Chrome-based example. Style sheets are the highest priority by default. If you set a fetch priority of high, it's going to retain the highest priority. If you set a fetch priority of low to a style sheet, instead of being a low priority, it'll be downgraded to a high priority. So in neither of these situations are we explicitly saying high or low priority. It's just adjusting it relative to the browser rules. A really good place to use this, image carousels that marketing teams love. If you set a fetch priority of high to the first active image, it will request that quicker and therefore download quicker, improving your performance metrics, particularly if it's in the viewport as part of the largest contentful pane. And then everything else, if you set it to low, they'll come after that first main one. So it's a really good way to utilize this, particularly in that top part of your page. Browser support is very good, I would say. Chrome, Safari, Edge, and the associated mobile browsers. Not supported in Firefox, but they are actively working on it. But the best thing about HTML, it'll just ignore it if it doesn't know what to do. So you can use it. You don't need polyfills or anything like that. Just use it in the other ones and wait for Firefox to support it. So the next thing I want to talk about is requesting a resource from the server. This can take a really long time, so if you can handle it ahead of time, you can make your websites and applications feel a lot faster. And to do this, we use resource hints. There are 2 options that we're going to talk about: pre-connect and DNS prefetch. And the way that we use them is with the rel attribute. So rel pre-connect, rel DNS prefetch. You can apply this to a link element in the head of your document. If we look at pre-connect first, essentially it's going to inform the browser that your page intends to establish a connection to another domain and that you'd like the process to start as soon as possible. So you can speed up load times by about 100 to 500 milliseconds by establishing early connections. Really handy for image CDN, streaming media. However, if you're making a lot of connections to third-party domains, pre-connecting to all of them is counterproductive. So it's best to pre-connect only on critical connections. For everything else, you can use DNS prefetch, which will save time on the first step, the DNS lookup, which is usually about 20 to 120 milliseconds of time. Now, that might not seem like a lot, but in a positive way this time, it all adds up. If you can save 50 to 100 milliseconds multiple time on multiple resources, you'll start to see a lot of performance improvements. Pre-connect has great support. DNS prefetch, Firefox only supports on HTTP, not HTTPS. It's also not supported in iOS, Safari, or in the Android browser. But again, HTML, you can still use it in the others. Finally, we're going to talk about preload. Preload is probably the most commonly used performance HTML thing. We use it the same way that we use the other two I just talked about, with the rel attribute on a link element and a value of preload. What it does is help to prepare resources that you don't need right now, but you're going to need later. So keep in mind, again, when you preload one thing, you prioritize that and you deprioritize another. So you only want to use that on critical connections like pre-connect was used. Unfortunately, people kind of use it everywhere. Zach Leatherman did this great tweet, which I loved. If you use preload on everything or in the wrong places, you can actually make things worse. So I'm going to use this example from Robin Marks, which is actually a response to that previous tweet, which I thought was amusing. Basically, we've got an example without preload and with preload. And on this, sorry for everyone over there, but I can't reach that way, we've got HTML, JavaScript, and an image. And on the first example, the image request is deferred until after the JavaScript is downloaded, and it takes about 2.25 seconds, which is kind of a long time. With the second example, the image is requested alongside the JavaScript, and it's downloaded quicker, which is great. Unfortunately, you can't see the bottom because of the text, but what is more likely to happen is not that middle one. What's more likely to happen is your image and your JavaScript are going to fight for bandwidth and priority, delaying both the JavaScript and the image download. And in some cases, the image might download it before the JavaScript, creating a janky page experience. So you need to be careful about how you use this stuff, and you need to test it because it might not give you the results you were expecting. Preload should be used for assets that are not loaded directly by the HTML, but are critical to the page experience. So things inside CSS, like fonts and images. Things that JavaScript can request, like JSON, imported scripts, web workers, or of course large videos, large files that you need to pre-start downloading. So, to finish off, I wanted to talk about 103 early hints. Not HTML. It is a HTTP status code called 103 early hints. Now, the reason that I wanted to mention this is because what early hints does is it defines new interactions between a client and a server, and you can utilize everything that I've just talked about. DNS prefetch, preload, fetch priority, and pre-connect. So, for example, it will allow the browser to pre-connect to sites or start preloading resources even before the server has prepared and sent the final response. So while the syntax is a little different, what I thought was great about this was that it's transferable knowledge. You know, if you live in that land more than you do in HTML or vice versa, you're learning something that you can apply in multiple places. And sometimes you'll find that it's better in early hints versus HTML and vice versa. Support's pretty good. Preload is only not supported in Safari and behind a flag in Firefox. So, what I want to finish up by saying is, please make the most of HTML. Spend a bit of time learning it and how you can apply it to your pages for your content. You'll make things more useful, more usable, not just for performance and accessibility, but for our users and different technologies as well. And all by using a technology you're already using, just using it a little bit better. There is so much to be gained from using HTML well. It's not difficult to learn, and there's absolutely nothing to lose. Thank you very much. I hope you got something out of my talk. If you have questions, please come speak to me or all my social networks. My resources are up on GitHub through this QR code. Thank you.